Hi, I'm Mike from Hunter Technical Support Department, and in this segment we'll be reviewing basic valve operations. If you're trying to locate the valves in your yard, here we have a typical installation with 4 or 5 valve boxes, and here at this end is a 1-inch ICV valve. It was installed with waterproof style connectors. The wiring leads over here to the solenoid, which is what electrically actuates the valve. In the middle we have the flow control handle, and the flow control handle regulates the amount of water that passes through the valve when the valve opens. In the center of that we have the manual bleeder screw. That will manually actuate the valve, and as well there is an AccuSet pressure regulator. That's a field installed accessory. It allows you to dial in the exact pressure that you want for after the valve. To manually operate the valve, one would take the solenoid and turn it a 1/4 turn counterclockwise. You'll hear the water start to flow. Let go of the solenoid, and after you've done your field check on the heads and you're ready to turn the valve off, simply turn the solenoid a 1/4 turn clockwise, hand tight, don't overdo it, you'll feel it stop, and then you'll hear the water stop. So here we have a ICV inline valve. On the topic of general valve operations, we'll start by identifying the various parts of the valve. And here in the lower half is the valve body, and the upper half of that is called the valve bonnet, and that's held down by the screws. In the center portion we have the working part of the valve, which is called the diaphragm. And on top of the diaphragm we have a center stem that goes up to a flow control handle. The flow control handle regulates how far the diaphragm opens and allows water to go through when the valve does open. On top of the flow control screw, we have what's called the manual bleeder screw. And opening the manual bleeder screw allows the water to evacuate out through that hole, and it allows the diaphragm to open, thus the valve will open with it. Beyond that, we have the solenoid, and that's what receives the electricity from the controller. The solenoid has a plunger on the bottom. When it's electrically activated, the plunger will raise up, and when it raises up, that little rubber gasket comes off of its port and allows the water to go down the exhaust port, thus decreasing the pressure on top of the diaphragm, allowing the diaphragm to move up and allowing the water to flow out to the field. The diaphragm operates off of something called surface area differential. And as you can see, the diaphragm sits horizontally in the valve. The top surface of the diaphragm here is much larger diameter than the bottom side, as you can see here. So the difference in surface area is what creates the differential. The top portion of the valve has something called a bonnet chamber, and you can see that inside here. At idle, the diaphragm sits down on the diaphragm seat, and there's no escape of the water here on top, so it's pressurized. The plunger is down, it's not allowing water to escape, so that pressure sits on top of that diaphragm. When the controller turns on the valve electrically, the plunger raises up, and the pressure and water that sits on top of the diaphragm is allowed to escape down the exhaust port and downstream. Once that water escapes, the pressure here drops, and it allows this diaphragm to move upwards off of its seat, allowing the water to escape downstream to the heads. You might also have something called the anti-siphon valve. This is not an inline valve that goes in a valve box, but it mounts above ground, usually about 16 inches off the grade. And this happens to be a slip joint style, but it works off the same premise. The front half is the anti-siphon portion, and the back half has the body, the diaphragm in between, the same flow control, and the same solenoid and a manual bleeder screw. This is held down by 4 screws, and the larger ICV inline is held down by 6 screws. So that's the basic premise of how valves work.